Sorry about that. Hi, I'm Salvador Mascarenhas. This is WooJin Chung. We're going to jointly present our talk. We're sorry if this is an unusual thing. It's common in our field. We apologize for the weirdness. We're going to be telling you about question-answer dynamics and deductive fallacies without language. So let's start by taking a look at some deductive fallacies that we're going to turn into visual stimuli. These are known as illusory inferences from disjunction. They were discovered by Claire Walsh and Phil Johnson-Laird in 2004. They go like this: John speaks English and Mary speaks French, or else Bill speaks German. John speaks English. Can you now conclude that Mary speaks French? As I expect you to confirm introspectively, it's an extremely attractive inference, accepted over 80% of the time in experiments replicated multiple times with an enormous range of variation of content. It doesn't seem to matter how you express disjunction in English, and we have, importantly, absolutely comparable rates of fallacious conclusions. If instead of proposing a conclusion, Mary speaks French and asking, does this follow, we simply give them premise 1 and premise 2, and we allow them to give a free-form response. What do you think follows? So they will happily volunteer. A comparable percentage of people will happily volunteer at this conclusion. It is a deductive fallacy in that it is this inference is falsified at a model where Bill speaks German, making premise 1 true. John speaks English, making premise 2 true, yet Mary does not speak French, the coherent situation. Conclusion is false premises are true, inference is invalid. I can give you more detail in the question answer period if you're interested, but this is also not probabilistically valid either under absolutely standard assumptions. So there seems to be a fallacy that is worthy of explanation. The original accounts of these kinds of fallacies come from the mental models tradition, where disjunctions, sentences containing or, are very, very special. They give rise to sets of mental models, unlike, say, conjunctions or other connectives, which give rise to simple mental models that represent information, integrated information coming from the multiple propositions connected by the connective. Then the story goes, keeping track of these sets with multiple alternative mental models is quite costly. Therefore, humans attempt to match mental models that occur in later premises to mental models in earlier premises and drop from attention those mental models from earlier premises that fail to match with later mental models. That's all very abstract. Let's look at some pictures as to how this might go. So that first premise in the mental models account is a disjunction. John speaks English and Mary speaks French, or Bill speaks German, gives rise to a set of two alternative mental models, one of the first disjunct on the top and another of the second disjunct at the bottom. Then premise 2 comes in, John speaks English, and it turns out to match the mental model, alternative mental model at the top and not at all the one at the bottom. So the one at the bottom goes away. We forget about the possibility that Bill speaks German, disappears. All we're left with is the top possibility that John speaks English and Mary French, whence the observed conclusion that Mary speaks French follows via some mechanism that allows you to extract a part of a mental model. This account produces the fallacious behavior. It has at least two important unresolved questions in our view. First of all, there's a why question. Why is natural language OR so special? Why does OR produce these alternative mental models, these costly, complex representations, as opposed to other connectives? And there is a understudied role of scalar implicature or pragmatic phenomenon, more on which shortly. First, the why question. Why are disjunctions so special? We submit that there are some interesting insights from linguistics that provide a reason for this. So it's a well-known fact to linguists for at least 150 years that very many altogether unrelated, historically unrelated languages share morphemes for disjunction and question-forming operators. This is a rather large Sprachbund of East Asian, South Asian, and Slavic languages, again, historically unrelated. That display this property. Here's an example from Malayalam, a Dravidian language spoken in India. You see on the left-hand side that little morpheme O attaching to noun phrases, to names in this case, and producing a disjunction, John or Mary showed up, declarative disjunction. And on the right-hand side, the exact same morpheme O attaching this time to a verb and turning a declarative into a yes-no question. So very, very common phenomenon in the languages of the world. Besides this morphosyntactic convergence, there are also some theory internal reasons within linguistic semantics for positing the same kinds of model theoretic objects as analyses for both questions and disjunctions. We don't have time to go into those details. We'd be happy to comment on it later. This insight allows us to recast this the mental models account in terms of question and answer dynamics. Here's how the story goes informally. This can all be turned into a theory. The citations are over there, but intuitions are all we need for now. So the first premise, John speaks English and Mary speaks French, or Bill speaks German, by virtue of being a disjunction, provides some information, some declarative information, but also poses a question. A reasoner that's considering that just interpreted this question is now wondering, am I in a John speaks English and Mary speaks French situation, or am I in a Bill speaks German situation? And this reasoner is now interested in deciding between these two situations. She now hears the second premise, John speaks English, and attempts to interpret it as an answer to the question she is considering, prompted by the experimenter. And of course, interpreted it as an answer to the question under discussion. Any reasonable theory of discourse pragmatics and dialogue will predict that John speaks English is, of course, an answer in the red direction rather than in the blue direction. So the reasoner now concludes, oh, I see, the first answer is right, the red stuff is right, whence it follows that Mary speaks French. This kind of question answer dynamics and reasoning accounts not just for these fallacies that we're telling you about today, it's important to observe, but also for a relatively diverse host of deductive fallacies with other question-like elements. That is to say, other elements than disjunction that linguistic typological facts and theory internal observations lead us to believe are like questions in that they are related to are like disjunctions in that they are related to questions. This is the case, say, of indefinites like the quantifier sum. It also extends to problems in the broad category of reasoning by representativeness. Take the conjunction fallacy, which I'll assume you're all familiar with. Participants are asked to choose the most likely option from between Linda is a feminist bank teller and Linda is a bank teller. They are considering a disjunction, really, trying to answer this question. And they see some information, a rather detailed description that interpreted as an answer to the question at hand clearly must be interpreted as a desire to communicate that the right answer to the question is feminist bank teller, whence the fallacy. So this kind of question answer dynamics actually allows us to provide an answer, a reason, a justification, and a theory of a lot of stuff in reasoning. There's a potential confound to this story that I just told you, which is scalar implicature. Modern linguistic theories predict that first premise, let's consider just its logical structure, A and B or C, should actually be interpreted in a much stronger way. Informally, these theories say that you basically have an unpronounced counterpart of the word only that applies liberally to expressions. So basically, the first premise predicted to mean only A and B or only C. That is to say, A and B and not C, or C and not A and not B. If this is the interpretation of the first premise, then along with the second premise, which says A, the conclusion B actually does follow perfectly validly, perfectly rationally. So that these inferences might actually be the result of well-understood interpretive processes. That means it looks like we have two sources for the same behavior. There is question-answer dynamics that would produce the observed conclusion, and there's also purely interpretive processes of scalar implicature that assume absolutely no interesting facts about the interaction between the premises. The goals of our study then were to remove language from the equation in order to investigate these two avenues. First, by trying to see whether non-linguistic materials can trigger question-answer dynamics. Question-answer dynamics very plausibly depend on communicative contexts, but they absolutely needn't depend on language proper. Secondly, we wanted to altogether block the scalar implicature that provides an absolving interpretation for premise 1. Now I'm going to skip the last point for reasons of time.
And here's our experiments. We developed animations representing a water-based mechanism. Water flows from the basin at the top through the pipes, and it can be blocked by a number of gates potentially. As we will soon find out, the structure of the pipes and the arrangement of the gates jointly convey a particular logical structure. We initially had two familiarizing trials. The first one shows how the gate works. They can allow the passage of water. They can rotate, blocking the passage of water. The second one introduces the occluder, and the occluder can hide the gates, which can rotate behind the occluder, and the occluder has windows that can open to reveal the state of the gates. And this is our first critical target trial, which we call the Y. Initially, the water is blocked by two mechanisms on the left and the right. There are two gates on the left, one on the right as well. And then the occluder closes and covers the gates. all of a sudden water flows down the pipe and conveys a premise 1, which is are the two gates on the left open, or is the one on the right open, A and B or C? And then we reveal that gate A is open, which is basically premise 2, A. So, and then we ask the subjects, can you conclude that mechanism B is guaranteed to be open? And this is basically A and B or C, then A, then we're asking about B. And if the subject says yes to the question, then she fell for the fallacy. And here's the full animation. Initially, the gates are closed. Water flows from the top, blocked by the gates. And the occluder covers the gates. All of a sudden, water flows down the pipe. What happened, A and B or C? And we reveal A, and then we ask the question, can you conclude that gate B is guaranteed to be open? We also had the baseline trial, which basically measures the baseline preference for the B gate. So it is identical to the target trial, except that we do not reveal that gate A is open. So we just give the premise 1, A and B or C. Can you conclude that B? We also had two control trials, one of which is disjunctive syllogism. So here we're basically trying to convey A and B, A or B, not A. Then is it the case that B? So both of the gates are closed, and then water they're covered. The water flows down the pipe, and reveal that A is closed. That's not A. Then we ask whether B is open, where the participants should say yes. We also have no control, which is basically similar to disjunctive syllogism, but with an additional disjunct. So this is basically A or B or C, not A. Then we ask about B or C separately. And you should say no to this. There's actually a potential compound in this design, which is that the two gates on the left are physically connected and are close to each other than on the gate on the right, and it could potentially induce a low-level visual bias connecting gate A and B, like fluid dynamics and so on. Therefore, we try to eliminate this compound and develop what we call the diamond scenario. Here we have two gates on the top, A and B, and one on the bottom. Initially, they are open as opposed to closed in the Y scenario. Water flows down the pipe, and then occluder closes, and water all of a sudden starts. The water flows from top, and all of a sudden the water is blocked. And then we add this will convey that either A and B, the two gates on the top, are closed, or the one on the bottom. So it's basically premise 1, A and B or C. And then we reveal that A is closed. That's the second premise. And then we also ask the question, can you conclude that mechanism B is guaranteed to be closed? This time it's closed as opposed to open. And then if the subject says yes, then again, she fell for the fallacy. We will skip the full animation for the sake of time. Happy to present it in the discussion session. We also had baseline, just like the Y scenario, where we collect people's base preference for the B gate with premise one alone. And we gave them a yes control that correspond to disjunctive syllogism. We had a different setup because we are asking about whether gate is closed as opposed to open. And also we had a no control for it. And here are our predictions. Given that question answer dynamics don't depend on language, we expect a higher rate of fallacies in the target trial than in the baseline or no control trials, despite the absence of language. We also expect to find lower rate of fallacies than in the experiments with language, the Johnson-Layer original experiments, since scalar implicator cannot be calculated without language. We recruited 200 participants for the diamond and another 200 for the Y, and tested the target versus baseline conditions in a between subjects design, since these two trials are very similar. We will directly go to the contrast analysis since it's more concise and conspicuous. Focusing on the diamond scenario, we found significantly more mistakes in the target trial than in the baseline or no control trials. In the Y scenario, we found a similar trend as well, since the estimates are negative, but the contrast between target and baseline was not significant. The figure on the right-hand side, plus the proportional yes responses, which indicates the rate of fallacies. And the participant overall made more mistakes in the diamond scenario than in the Y scenario, but the trend is clear. This suggests that question answer dynamics is possible with minimal language, and the fallacy rates are lower than in the language version, and like 42% in the diamond and 19% in the Y, which suggests that the scalar implicature avenue to the fallacy is a significant contributor to the linguistic version. We hope that you're convinced that by now that question answer dynamics do not depend on language. However, do they depend on communicative intentions? The participants know that the videos were made by us and are plausibly thinking about our communicative intentions. We would like to address this question in the future work. And also, you've already noticed that there were low fallacy rates in the Y scenario. So we actually recently redone this on adults with child gear animations with larger sample size, same exercise, which was like around medium, which was for this experiment as well. But we also have statistically significant results. And we also have ongoing study applying this paradigm to invasive preschoolers. Thank you for listening, and do let us know if you have any questions.